Okay, let's take a closer look at how data hops the network in terms of layer 2 and layer 3 addresses. Let's say that station A is going to send data to station B. Now, station A knows, and let's assume everything in this diagram, by the way, has a Class C standard subnet mask, 255.255.255.0. Station A is going to send data to station B. Station A knows that station B is on a different subnet because it knows its IP address and its subnet mask, knows that it's on the 192.168.1.0 network, and it knows that station B is on the 192.168.2.0 network. So because station A knows this, when it sends data to station B, it knows it's going to have to go through its router. So let's take a look at what happens in the addressing structure of the layer 2 and layer 3 headers. Let's first look at the layer 3 header. Now the layer 3 header has a source and destination IP. So the source IP is going to be 192.168.1.2, and I'm just going to put the 1.2 to make the numbers look a little easier. And the destination IP address is going to be 192.168.2.2. This will never change these addresses as we hop the networks from the first router, let's just call it router 1, and as we hop the network to router 2 and then on to the final machine, this header, this layer 3 header here, is not going to change. Layer 3 will not change it. Source IP will always be 192.168.1.2, and destination IP will always be 192.168.2.2. Now what does change, however, is the layer 2 addressing. Layer 2 addressing will change after every hop. Layer 3 addressing can never change. If it did, the workstation B over here would never know who the data came from if the IP address changed en route, and if the destination IP were to change en route, it would never reach station B. But now layer 2 uses a source MAC address, for Ethernet at least, and destination MAC address. Now A does not know station B's MAC address, nor is it feasible to learn the MAC address of a workstation that's not on your subnet. So what does the layer 2 address look like in this case? Well, the layer 2 address for source MAC address will be 12.11-FD-3C-2E-13. That's this MAC address here that I'm putting the circle around. That'll be the MAC address for A. That'll be the source MAC. Let's just call it A, so we don't have to write those 12 digits out. It'll be the source MAC address for workstation A. Destination MAC address. It will not be the destination MAC address for workstation B. Again, this station, we've only shown it 2 router hops away, but it could be 1,000, it could be 100 router hops away around the world. Who knows how far we may have to go. It could be significantly far away. So we're not necessarily going to know the MAC address of workstation B. What we're trying to do is get the packet on the first hop to our router because we already know we're going to have to go off of our subnet to get to B. We know this because workstation A speaks TCP/IP, and workstation A knows that the destination address is not on its subnet for the reasons we mentioned earlier. So the destination MAC address will be router 1's MAC address, the one I'm circling here, for its Ethernet port here. In other words, the IP address 1.1 is bound to the MAC address that I just circled. And let's call that destination MAC of router 1, so we don't have to write out all the hexadecimal digits there. So that's what's going to happen in the first case. What's going to happen is data is initially going to transmit from A, and it's going to broadcast out the switch, or it's going to be sent out the switch to the port that is aware of the 1.1 address, which is going to be the MAC address corresponding to router 1. The way we knew the destination MAC address for router 1 is we ARPed for it. So remember back to where we discussed ARP, We knew we were going to have, workstation A knew he was going to have to transmit off segment. So he said, hey, I'm going to have to communicate with the router. So he ARPed for his router's MAC address. He knew who his router was because in the TCP/IP configuration parameters, we had told that workstation that 1.1 was his gateway. So he said, listen, 1.1, tell me your MAC address. And the router would respond with 192.133.55.AAF0 in this case. We call it R1 over here just to be shorthanded. So the layer 2 address, source MAC is A, the destination MAC is router 1. This interface here. Now, we're not ultimately wanting to get here, we just want to get it to router 1 for now. The IP address is what's going to get it all the way across the network or all the way across the world. So when this is just step 1 for layer 3 and layer 2. Now let's take a different color pin here just so we can show the difference. Now let's take a look at what happens at that point. At this point, the router says, all right, I'm going to transmit out the path to 2.2, and we'll talk about in next semester how the router knows which path to take. But in this case, he needs to go out the serial connection that's corresponding to the 201.33.55 network. So what is the source IP going to be this time and destination IP? Well, if you said the same thing, you would be correct. We don't need the intermediate IP addresses 201.33.55.17. All we're doing is picking interfaces based on a routing table. We don't really need those IP addresses. The layer 3 IP address of the packet, source IP and destination IP of the packet does not change. It's going to be sent out the serial port over to this router. These are point-to-point connections. These are the only 2 devices on this serial link. Because of that, we don't need a layer 2 address. So in this case, there'll be no layer 2 address for this second hop because the only station that can hear this interface over here on the left, the only station that can hear the interface is this one over here on the right. So it's going to get to where it's going. It's the only place it can go. So this interface over here on the right picks it up and says, look, we're trying to get to 2.2. Where should I go? Well, of course, the router knows where that is. It's going to be out this interface because he owns the 2.0 network over here on the right. So what's going to happen now? Let's take another look at use another color for this. Now from here to here, what does the layer 3 address look like? Well, the layer 3 address is going to look just like it did before. Source IP and destination IP, 1.2 and 2.2. Now I'm not writing out the 192.168 just to make it look neater on the board, but obviously that part would be there. But the source IP is over here at 1.2. The destination IP is over here at 2.2. That never changes, notice, as we're hopping the network. Now what will the layer 2 address look like? Well, the source MAC address will be the MAC address of the router's Ethernet port, which in this case is this MAC address here. Let's just call it router 2's Ethernet MAC address. And the destination MAC address will be what? It will be workstation B's MAC address. We're on the same subnetwork, so we're able to know both MAC addresses here, R2 and B. So we'll use B's MAC address. So what I want you to get out of this is understanding how data hops a network. I want you to understand that layer 2 addresses can change at each hop, or not even be there sometimes at each hop, the layer 2 address. But the layer 3 address always stays the same. That way the data can get there and the data can get back. And this is one of the reasons we're divided up into layers in the network. All right, review this again if you need any help. This is an important concept to get down, so watch this as many times as necessary or ask your instructor for help.